All right, good morning, fifth graders. For the last couple of days, we have worked on finding the formula or using the formula to find the area for a right triangle. Well, today we're going to tweak that idea and that lesson just a little bit. We are going to change it from the term right triangle to any triangle. So again, very simplistic, should be a small change, a small tweak, and really only one major difference from what we've already dealt with. All right, so as you are looking in the upper right-hand corner here, you should see a parallelogram. If I were to change that parallelogram just slightly and make it a true rectangle, the reason we've kind of progressively worked up from the rectangle to a parallelogram is that with a rectangle, we have a built-in height and a base because we already have a perpendicular line or a right angle. So when I draw this diagonal going down, we don't have to try to figure out what the true or actual height of that shape is. So there wasn't that extra step. As we look at this parallelogram, and if we think back to our lesson on finding the area of a parallelogram, we remembered that the difference between a rectangle and any other generic parallelogram is that we don't have a perpendicular height with the shape. The parallelogram kind of looks like a rectangle that has taken a nap. It's kind of leaning over. And when we try to find an actual height of something, we need to end up with a perpendicular line or a completely vertical line from our base. Okay, so that's where our dotted line or our green line comes in here. And again, we're going to identify that that is the height based on the right corner or the 90-degree symbol that we see in the corner of that line and the base. All right, so that is the only difference. The formula itself will stay the same. Again, depending on how you want to write it, area equals half of the base times the height, or the area of that triangle would be base times height divided by 2. Either one of those concepts or formulas would work. However you want to look at that. I think the majority of us eventually end up solving these area problems of a triangle simply by taking the two numbers, multiplying them, and dividing by 2. All right, so as we look at today's couple of problems, we're only going to do about 3 problems today, guys, so it should be fairly straightforward. We should be looking here at this first triangle. Now I've got a little bit up here. I made a mistake earlier, so get rid of that. All right. Notice that we do not see an entire quadrilateral there. We don't see a parallelogram. So we have to, again, in our mind, remember that just because we see those two numbers, we are not just going to multiply those two numbers, but since we are looking at a triangle, we have to imagine and envision that that parallelogram is there already, and then divide that into 2. What we are looking at here is, again, something that might come across like this and down like this. So we are looking at a parallelogram with a base of 48 and a height, like they are pointing to the area of our perpendicular line here, of 15. And when I multiply 48 by 15, let me do a little math here and try to figure that out. It should be about 720. All right. So the area of the entire quadrilateral would be 720 centimeters squared, or square centimeters. Doesn't matter, again, how you label it, as long as we have square involved in it somehow. But now we need to find the area of just this triangle. All right, so again, that is half of that shape. All right, that is half of what we are looking at here. So we need to cut 720 in half, and we would do that by dividing by 2 or multiplying by 0.5. Again, if you're using a calculator, that would be a way we could do that without having to multiply by a fraction. So 720 divided by 2 is 360 square centimeters, or centimeters squared, again, however you want to choose to label that. Now, when we answer our problems in Schoology, guys, remember that there is not a number 2 exponent, so we are going to try to stay away from that and probably answer it as square centimeters. That abbreviation that you see there is probably the easiest one to do. All right. So now let's move over to question 7. Now here, again, is the difficulty, I think, with triangles, guys. We automatically assume in our mind, I think, that the base is on the bottom. It's what it sits on. Well, if we look at this, technically in my mind, this is the base, but we can't have a point be the base. So what we are looking for and what we are trying to identify is where is that dotted line, because the dotted line will actually be our true indicator of our height. So as we look at this dotted line and this square corner, kind of odd for us to think that 4 would be the height, but all we would need to do is rotate that triangle so that it is sitting on the base of 9 feet and that it is rising up straight from the base 4 feet. All right? So that's the idea here, is you have to identify where is the height, where is that square corner, where is that 90-degree symbol, and what are the two sides that come out of, or the two lengths that come out of that angle. All right, so in this one, it is dead center in the middle of the base where that straight line comes up to reach its peak. So we are looking at 9 times 4, which gets us to 36. But again, that would be if this was a full parallelogram. We are looking at a triangle. We need to remember to divide by 2. So 36 divided by 2 would get us an answer in this case, guys, of 18 square feet this time instead of centimeters like we had in the last question. Looking and identifying what that label is very important as well. All right, on the next one we have some large numbers here, guys, but again, nothing that we can't use if we have the ability to use a calculator for it. Now it's just a matter of understanding the formula and plugging those numbers in. All right, so as we look at number 8 here, guys, and I'm putting the area of any triangle up here. Now this just happens again to be a right triangle. We don't see any dotted line, but we do see a 90-degree symbol, that square in the corner of that triangle. So we're kind of going back to that last lesson with this one, right? And so we are looking again for the base, in this case, base of 82 times the height, that made a little bit different sizes here, of 125. So as we multiply that out, we should end up with something around the range of, I think, 10,250. All right, 10,250. And again, you've got the ability to plug that into a calculator to check that out for sure. Might want to check my math on that just to make sure that I'm correct with that. But then we need to take that answer and divide it by 2. Okay, so take that and plug it into a formula, and we should end up, in this case, guys, with an answer of 5,125 square meters in this case. Again, identifying the label as being different, or meters squared, but again, with Schoology, we don't have that access to exponents. So hopefully this is a nice introduction for you guys. We will do a second day of this lesson as well, because this formula and understanding how to find the area of these triangles, any triangle, is going to be hugely significant as we move forward to finding the area of other shapes, both complex, composite 2D shapes and regular pentagons and hexagons and things like that. Knowing the area of a triangle is hugely, or how to find that is hugely important moving forward in geometry, guys. So please make sure you are asking questions if you don't understand. Make sure you are checking your work to make sure you are correct with that. And if you aren't understanding it, like I said, make sure you're setting up a meeting with me and we can discuss maybe where the issue is. Don't forget that you can use a calculator to help you solve these problems. All right, please complete the exit ticket listed below this video, and I look forward to hearing from anybody who has a question.